Alright, so now that we've talked about what are systems of equations, we're going to talk about how do we solve them if graphing is not the way that we want to do this. There's two methods to solve systems of linear equations. The first one that we're going to look at is the substitution method. In order to be able to do this section, you do need to be able to solve complex linear equations involving distribution. You need to be able to solve for an indicated variable. You need to be able to find the second coordinate of a point given the first. And you need to be able to check if a point is a solution to a system of equations. Upon completing this presentation, you will be able to solve a system of linear equations by plugging an expression into an existing equation. So let's talk about the procedure in order to solve a system using substitution method. In order to do this, the first thing that we want to do is solve for a variable in one of the equations. To make this as easy as possible, choose a variable that has a coefficient of 1 or no coefficient. We're going to then substitute the expression we found in step 1 into the other equation. We're going to solve for the remaining variable, and then plug the value you found from step 3 into one of the original equations and solve for the remaining variable. Finally, check your solution by plugging both numbers into both equations. One thing to note is that if every term has a coefficient, then substitution method becomes a lot harder. In that case, we don't use substitution method. We will use our second method, which we will discuss in the next lecture. So to give you an idea of how this works, let's say that we have x equals 3y minus 7, and let's say y is equal to 2. Well, how would we solve for x? The trick to this is I'm going to take my 2 for y and plug it into the original or the first equation. So we get x equals 3 times 2 minus 7, and we would continue solving. We would go ahead and multiply. 3 times 2 is 6, minus 7, and we would get x equals -1. So this is stuff that we've been doing for quite a while now. Remember that when we talked about graphing linear equations using tables, this was the method that we used. We picked values, we plugged them in. Well, the main thing to remember is with substitution method is we're going to be doing the same thing, except that instead of plugging in numbers, we're going to be plugging in expressions. But keep in mind, it is the same basic concept as what we did right here. We take the 2 and plug it in. This may be something longer, but we will still do the same thing. We will plug it in for the variable. The other thing to keep in mind with substitution method is that we can solve for x, we can solve for y. In the previous chapter, we were always solving for y because we wanted to write in slope-intercept form. But when we're talking about substitution method, it does not matter which variable you solve for. You always want to pick the one that is easiest. So now let's go ahead and look at some examples of what substitution method is going to look like. So we have example A, y equals -x minus 1, and 4x minus 3y equals 24. So this particular problem, we don't have to worry about solving for an indicated variable. We already have y equals something, which means that I'm going to take this expression x minus 1, negative x minus 1, and I want to replace y in my other equation. So if we do this, we get 4x minus 3 times negative x minus 1 equals 24. From here on out, this is similar to when we were working with equations in Chapter 2. So what we want to do from here is go ahead and solve for x. We're going to go ahead and distribute the negative 3. So we get 4x. We get negative 3 times negative x is plus 3x. And we get negative 3 times negative 1 is plus 3. We have that is equal to 24. We want to continue solving using the techniques that we learned in Chapter 2. So we're going to go ahead and combine our like terms. We have 4x and 3x is 7x plus 3 equals 24. We can subtract 3 from both sides, giving us 7x equals 21. From here, to finish solving for x, we're going to divide by 7, and we get x equals 3. Now, in previous chapters, that would have been enough. But the thing to remember here is that we have both an x and a y in our original problem. So what I need to do from here is take 3 and plug it back into an original equation in order to find y. So let's plug it into the first equation. That one looks a little easier to work with. But ultimately, it does not matter. So if we plug this in, we get y equals minus 3 minus 1. And if we simplify this, we get y equals negative 4. So my solution is 3 comma negative 4. Remember, points are always written x comma y. You can also just leave it like this. Okay, so we've gone ahead and found our solution now. So now let's go ahead and check our answer. If we check our answer, we want to go ahead and plug both of these coordinates back into the original equations. So in my first one, we had y equals negative x minus 1. If we plug in, we get negative 4 equals negative 3 minus 1. If we simplify the right side, we get negative 4 equals negative 4, and that checks out. So we're good. One of these equations is going to be kind of redundant. The one that we used when we found our second coordinate is generally going to be the one that checks out, unless you did something really wrong. But the second equation is the one that we want to really make sure that this works in. So my second equation was 4x minus 3y equals 24. So if we plug into this one, we get 4 times 3 minus 3 times negative 4. And I want to know, is that equal to 24? So 4 times 3 is 12. Negative 3 times negative 4 is also positive 12. And if we add 12 plus 12, we get 24. So yes, 3, negative 4 is the solution. Okay, so that's kind of a base case problem. So now let's go ahead and look at one that's going to be a little bit more involved. Let's go down to example B. So example B, we have 5x minus 4y equals 9, and x minus 2y equals negative 3. The first thing to note on this is that neither variable is solved for. We don't have x equals this or y equals that. So the first thing we need to do is solve for one of the variables using our procedures for solving for formulas. So the variable that I'm going to solve for is going to be x in the second equation. Why do you think that is? Correct. The reason is because solving for x in terms of all these other variables, this is the easiest one to solve for. All I have to do is get rid of the 2y term, and then we're done. So if we go ahead and solve for x in the second equation, in order to do this, all I have to do is add 2y to both sides. And you will get x equals 2y minus 3, or negative 3 plus 2y. It doesn't matter how you write it. Okay, so now that I have solved for x, my next step is I want to take this and plug it into x in the other or the first equation. So if we do that, we get 5 times 2y minus 3 minus 4y equals 9. So now let's use our techniques for solving linear equations. I want to start by distributing. We get 5 times 2y is 10y, and 5 times negative 3 is negative 15. We still have minus 4y, and we still have that this is equal to 9. We can go ahead and combine our like terms now. We get 10y minus 4y is 6y. Bring down the minus 15 equals 9. In order to solve for y, I want to start by moving my constants to the other side. So we get 6y equals 24. And then if we divide by 6, we get y equals 4. Okay, so we have found y. I still need to find x. So I'm going to take this and plug it back into an original equation. I'm going to go with the second one. So if we plug this into the second equation, we get x minus 2 times 4 equals negative 3. We can multiply the negative 2 times 4, giving us x minus 8 equals negative 3. And finally, I can add 8 to both sides, giving me x equals 5. So my solution is 5 4. Okay, let's go ahead and check this one as well. If we go ahead and check this, let's plug it into the first equation. My first equation was 5x minus 4y equals 9. If we plug this in, we get 5 times 5 minus 4 times 4 equals 9. If we multiply, we get 5 times 5 is 25, minus 4 times 4 is 16. I want to know, is this equal to 9? And yes, it is. So we're good there. Okay, so now let's plug it into the second equation. The second equation, we have x minus 2y equals negative 3. And if we plug this in, we get 5 minus 2 times 4. And I want to know, is this equal to negative 3? So if we go ahead and multiply, we get, I'm going to bring down the 5, minus 2 times 4 is 8. And 5 minus 8 is equal to negative 3. So that checks out. So our solution is in fact 5, 4. Or again, if you want, you can just leave it as x equals 5 and y equals 4. Okay, let's do one more example just to kind of cement this in our brains. Let's go down to example C. My next step is I want to take the 2x minus 3 and plug it in for y into my other equation. So if we do this, we get 5x minus 2 times 2x minus 3 equals 10. From here, we can go ahead and distribute the -2. We get 5x. We're going to bring that down. We get -2 times 2x is -4x. And -2 times -3 is +6. From here, we can combine like terms. We get 5x minus 4x is x, plus 6 equals 10. And if we subtract 6 from both sides, we are left with x equals 4. Okay, so we are done with finding x. The last thing we need to do is find y. So I'm going to take this and plug it back into an original equation. Again, it doesn't matter. For me, the easiest equation to work with is probably the top one. So if we plug this back into our original equation, we get 2 times 4 minus y equals 3. We can go ahead and multiply 2 times 4. We get 8 minus y equals 3. I can subtract 8 from both sides, giving me -y equals -5. And finally, we can divide by -1, and we get y equals 5. So my solution is x was 4, y was 5. Okay, let's go ahead and check this now. If we plug this back into our original equations, we get 2. We had 2x minus y equals 3. If we plug in, we get 2 times 4 minus 5. I want to know, is this equal to 3? Two times 4 is 8 minus 5. This is equal to 3, so we get 3 equals 3. That checks out. Now, if we check it in the other equation, we have 5x minus 2y equals 10. So when we plug in, we get 5 times 4 minus 2 times 5 equals 10. 5 times 4 is 20. Minus 2 times 5 is 10. And we get 10 equals 10. So this does check out as well. So our solution is correct, and that is the substitution method. So when will we see this again? We will be looking at application problems in the next section, where we will have more than one unknown. Anytime you have more than one unknown, you need a system of equations to solve. Later this semester, we will look at examples of applications using quadratics with two unknowns, though we won't see the term system of equations. We will be essentially using the substitution method in order to solve it. So now try the following problems on your own and bring to class, as well as any questions that you have. Please go ahead and pause the presentation so that you can go ahead and work on these before moving on to the next slide. As part of your notes, please answer the following questions. How confident are you with the material presented in this presentation? What from this section needs to be explained further? And how much more practice do you need to be comfortable with the topic?